Hello, welcome to Kent State College of Aeronautics and Engineering and the Industrial Electronic Robot class. This is developed by Dr. Boyd, and I'm Bob Philpott. I'm an electrician and faculty here at Kent State. I want to show you some robots that I've filmed over the past year doing assembly work for Ford Motor Company in Dearborn, Michigan and Avon Lake, Ohio. Two different styles of the aluminum F-Series pickup. Here we're in Dearborn, Michigan, and this is called a framing area. What we're doing is applying a door opening panel to the side frame of the pickup truck. And what's going on there right now is a riveting process. It's riveting the aluminum, and you notice that it looks, top of it is similar to, it's the door. You can see the door opening starting to form there. And there's hydroform aluminum inside that top for strength. And this robot's actually applying an adhesive to where it's going to go into the next sub-assembly. So we're using rivets, crimping, adhesives, some spot welding. But with this aluminum, it's more and more rivets. And this is going into what's called a geo fixture. And we've taken two different sub-assemblies and we're making one assembly after that. And what that's going to do is it's going to hold the opening for the door to hang. The next step here is the framing. What we have is a four-door pickup truck frame coming through there, and it's versatile automation these days. This is a four-door model. The next one that's going to come in is going to be a regular standard cab. It's got the small back doors, but you'll notice the difference in as we go through different jobs on this line. And also, if you notice, there is what we're looking into is inside a safety cell, so no people can walk inside this accidentally while this stuff's running. Safety first. But notice that different type of cab there that rolled out of framing one. And just wanted to show you the difference. There's two different. And this door opening panel in the foreground, notice that's a different style altogether. So it's a very versatile line. And we're putting in the final for framing one, and it's about to go over to the other side in the framing two. This is quite a marvel right here. There are 14 robots in one cell. You're going to learn about the DCS safety circuits and zones. This has 14 separate robots. If you notice, 3 across the top, 3 across the bottom, and 1 on the top, 1 on the bottom on the end, and the exact same, not mirror, but inverse image on the other side, doing the right and left hand side. It's more, like mirrored. But this is putting all rivets on at this station. And it's really quite a piece of engineering, this one single station, because you cannot have one robot running into the other. Here is Ohio Assembly in Avon Lake on the west side of Cleveland, and this was pre-launch. This was what I worked on when I transferred over to Avon 3 years ago, doing this launch. But it's FANUC robots as far as the eye can see. And here we have a standard regular cab F-150 come into a station, and it's going to put the roof on. And this roof's going to be riveted, sealed, and another called mastic, waterproofing. But if you notice, that gun just came in, a robot with its sealer and mastic it's applying. I broke away from that, and this is a monitor looking at a bird's eye view of that same operation, and you get a really good look at the application of sealer and mastic. And it's putting beads of this specific width and the amount prior to loading the lid, the roof on this thing. There's different ear tabs there that are going to get riveted, and all the way around 360 degrees around there is sealed because you can't have a leaky cab. But that is all checking for quality right there too. If you notice, this robot came in and it's setting there. Well, it's taking laser measurements right now to make sure everything's in place, and it's set that lid right on target. We're coming in the front and the back at this time with rivets, and first we're going to anchor it with rivets, and then there's another sealing process and some spot welds in the corner too. Okay, and this cut back away, that same operation, showing it going into the roof going into place right there. And if you notice, what's happening is we're also riveting up underneath the cab, and there's several places that you have ears sticking out in the front and the back, and those get riveted first. And then there's also a laser check after that in that same station to verify that it's airproof. And you notice also we're changing gun heads here. Those are two different types of rivet guns, two different rivet sizes. And these particular robots have two guns, so there's a tooling change, tool 1, tool 2, and they're separate programs, complete different operations, and you're having one robot perform two different tooling jobs. You didn't see any of this in Dearborn because the volume is so high there, you don't want to take the time for a robot to change its tooling. If you notice, it's a pretty long process changing the tools. So up there you have one robot with one gun on it, and here some of these have 3 different gun heads. You can actually have a rivet, a spot welder, clincher, sealer, different gun heads all going on the same robot. They're interchangeable. That's a base pedestal for an airproofing system. It's a Perceptron builds this. It's a laser airproofing system, and what you have are 3 spheres. They're set in a certain orbit, and it's anchored to the floor, and that is one of the reference points. And the lower part of this laser gun is the emitter, the one that's kind of longer there at the end, and there's 2 sets of lenses right there you see, and we're shooting out the emitter, and it reflects back into the collector. It's like a reflector back there, reflects back at a certain distance, and we have a known surface we're looking for with each measurement. So that's how we're getting a picture of what this surface looks like. Its dimensions, tolerance, the hole openings. If what happens then is the data is collected by our CMM department, and they keep it in for their records, and also if there's an issue, a recall or something like that, they can go right to this job and call it up, and every single point that this thing measured has a tracking number. It's actually a tag. It's got its own PLC tag, every single bit of that data, and it's really, in the future when you have recalls, they'll be able to go right to a particular bolt, screw, spot weld it, and find what that thing looked for and what the quality was when it was made. So there's a good record from this thing. And like I said, our CMM department, they're pretty diligent on keeping this and inspecting it a couple times a day by human eye. That's something else that happened with Toyota about 30 years ago. They realized it's good to have a set of human eyes somewhere to look at these jobs. You can have a lot of automation, but you still need a person, human interface. Here's the Econoline van that Ford discontinued. They still make what's called a cutaway van, and this is just the cab of the Econoline, and they go on commuter buses, campers, the motorhomes, and different work trucks. And these are FANUC robots also with sleeves over them in our paint department. And prior to this, they got a thing called E-coat they dipped it in, and this is actually a white vehicle. That's the real paint we're seeing going on there. and it's inside a sealed area. Temperature, humidity, everything is controlled in there, and of course clean. You gotta keep it real clean. And that whole part of the plant, you have to wear special. You know, you just can't go in there all dirty. They keep it. I hope you enjoyed the video. Congratulations on making robot and automation your career choice, and good luck with your studies.